Hello everyone. Welcome to the AI for All channel. We will now talk about topics 4 and 5 for the AI Renaissance in the 1990s to 2000s. After that, we'll cover 5, the revolution of deep learning in modern AI. For the AI Renaissance in the 1990s to 2000s. After the long period known as the AI winter, the field of artificial intelligence experienced a revival in the 1990s and 2000s, driven by technological advancements, new theoretical approaches, and especially the growing availability of computational power. During this period, the focus of AI shifted from purely theoretical attempts to simulate the human mind to more practical and efficient applications. This renaissance was characterized by a renewed interest in neural networks, advances in machine learning algorithms, and the rise of the Internet, which provided an unprecedented amount of data and connectivity. In the 1990s, one of the most important factors in the AI renaissance was the revival of neural networks. As mentioned earlier, artificial neural networks like Frank Rosenblatt's perceptron had been criticized and fell out of favor after the limitations identified by Minsky and Papert in 1969. However, the 1980s saw the introduction of new techniques for neural networks, such as the backpropagation algorithm, developed by Geoffrey Hinton, David Rumelhart, and Ronald Williams. This algorithm allowed neural networks to adjust their internal weights more efficiently during the learning process, solving some of the problems that had paralyzed previous research. Backpropagation gave neural networks the ability to handle more complex problems and learn from large amounts of data, something previous technologies couldn't do. This allowed neural networks to begin being applied to a range of practical problems, from speech and image recognition to time series forecasting. Although still limited by the computational power of the time, neural networks began to show their potential, and this technique became a cornerstone for the future development of AI. At the same time, another area of AI that gained significant prominence during this period was machine learning. While early AI research focused on algorithms based on fixed rules, machine learning brought a more flexible approach. Instead of explicitly programming a machine to perform a task, scientists began developing algorithms that allowed machines to learn from data and adjust their own parameters. This represented a significant breakthrough, as it made machines capable of dealing with highly complex and variable problems without the need for detailed manual programming for each new situation. During the 1990s, the development of techniques such as support vector machines, SVMs, decision tree algorithms, and Bayesian networks expanded the arsenal of tools available for machine learning. These algorithms were quickly applied in areas like pattern recognition, classification, and predictive analysis. One of the great successes of this era was the application of machine learning to the development of recommendation systems, which began to be used on e-commerce and entertainment websites like Amazon and Netflix. These systems made it possible to suggest products or movies based on user interests and behavior, a functionality that quickly became essential to the success of these platforms. Another important milestone of this era was the development of intelligent agent systems. Intelligent agents are autonomous systems capable of observing the environment, making decisions, and acting to achieve specific goals. They were applied in a variety of areas, from games and simulations to industrial control systems. One of the most famous examples was the creation of systems capable of competing in complex games against human players. This culminated in historic events such as the victory of IBM's Deep Blue over the world chess champion Garry Kasparov in 1997. The victory of Deep Blue was a historic moment for AI. Although the system was not a classic example of AI like machine learning or neural networks, its ability to analyze millions of possible moves and strategies in real time demonstrated the power of combining search algorithms with enormous computational power. Deep Blue used a brute force approach, processing a massive amount of possibilities to find the best move, which, combined with its ability to calculate quickly, outperformed Kasparov's intuitive reasoning in several matches. This feat brought significant attention to the field of AI and raised questions about the role of machines in intellectual human activities. Throughout the 2000s, with the exponential increase in computational power and the growth of the Internet, AI continued to advance. One of the biggest drivers of this progress was the advent of big data. With the Internet generating massive volumes of user data, transactions, and interactions, machines began to have access to an unprecedented amount of information to train their algorithms. Data, which had previously been one of the biggest obstacles to machine learning, was now available in abundance. This allowed scientists to develop more accurate and comprehensive models that could learn from large datasets rather than relying on limited examples. With the rise of big data, data mining also emerged, a technique that allowed companies and scientists to extract useful patterns from vast amounts of data. Machine learning was widely applied in this field, enabling automated systems to discover patterns and insights that would be difficult to identify manually. This had a direct impact on areas such as marketing, finance, and consumer behavior analysis, transforming the way businesses made decisions and connected with customers. Moreover, the increase in global connectivity led to significant advancements in areas like robotics and distributed intelligence. Robots began to be equipped with AI to perform complex tasks in dynamic environments, from space exploration with NASA to industrial robots capable of adapting to new scenarios and work environments. The emergence of collaborative agents and multi-agent systems also allowed machines to work together, sharing information and cooperating to achieve common goals. By the mid-2000s, AI was increasingly integrated into various industries and applications. The use of machine learning, neural networks, and big data ushered in a new phase of innovation, laying the groundwork for the AI revolution of the 2010s, when AI finally began to reach its full potential. 5. The revolution of deep learning and modern AI. In the 2010s, artificial intelligence underwent a profound transformation with the rise of deep learning. This approach ushered in a new era for AI, enabling significant advances in areas such as image recognition, natural language processing, automatic translation, and even games. Deep learning became the backbone of modern AI, responsible for bringing the field to prominence in both academia and industry, thanks to its impressive performance in various applications. Deep learning is an evolution of artificial neural networks that, although conceived decades earlier, only began to reach their full potential with the increase in computational power and the availability of large amounts of data. At the core of deep learning are deep neural networks, composed of multiple layers of artificial neurons, which allow the machine to learn complex data representations, surpassing the limitations of the simpler neural networks that dominated the previous decades. One of the first demonstrations of deep learning's power came in 2012, when the team of Geoffrey Hinton, Alex Krzyzewski, and Ilya Sutskever won the ImageNet competition, one of the most prestigious image recognition competitions, using a deep neural network known as AlexNet. This network achieved significantly better performance than other traditional machine learning approaches, reducing the error rate in image recognition tasks by more than 10%. The victory of AlexNet showed that deep neural networks could outperform traditional techniques when trained with large volumes of data and optimized with specialized hardware, such as GPUs, graphic processing units, which accelerated the parallel processing needed for deep learning. The success of deep learning in image recognition was followed by advances in other areas. In natural language processing, NLP, the use of deep neural networks led to significant improvements in automatic translation, sentiment analysis, text generation, and question-answering systems. A key milestone was the introduction of transformers in 2017, a type of neural network architecture that revolutionized language processing. This new approach became the foundation for advanced language models like GPT, Generative Pre-trained Transformer, from OpenAI, and BERT, bidirectional encoder representations from transformers, from Google. These models are capable of generating coherent text, understanding complex contexts in natural language, and performing translation and comprehension tasks with unprecedented accuracy. Transformers brought a paradigm shift in NLP, allowing models to process large amounts of text and learn richer, more detailed language representations. The impact was enormous, leading to the development of increasingly intelligent virtual assistants like Apple's Siri, Amazon's Alexa, and Google Assistant, which have become integral parts of the daily lives of millions of people around the world. These systems use deep learning to process voice commands, answer questions, and perform tasks, demonstrating how modern AI can enhance user experience in connected devices. Another area that was revolutionized by deep learning was gaming. In 2016, the victory of the AI AlphaGo, developed by DeepMind, over World Go champion Lee Sedol was a historic milestone. Unlike Deep Blue, which defeated Kasparov in 1997 using a brute force approach, AlphaGo utilized deep learning combined with reinforcement learning. This type of learning allowed the system not only to learn from past game data but also to play against itself, refining its strategies and improving its skills over time. Go, a board game with far greater complexity than chess, was considered a major challenge for AI, and AlphaGo's victory was seen as a sign that AI was reaching new heights in strategic capacity. In addition to gaming, deep learning has also been fundamental to the evolution of autonomous vehicles. Companies like Tesla, Waymo, and Uber began applying deep neural networks to enable cars and trucks to learn how to drive autonomously, recognizing objects, interpreting traffic signals, and making complex decisions in real time. The development of autonomous vehicles relies heavily on computer vision techniques, which use deep learning to process images and videos captured by cameras and other sensors on board the vehicles. These advances have promised a future with safer, more efficient, and accessible transportation. The healthcare sector has also been significantly impacted by deep learning. AI began being used to assist doctors in diagnosing diseases and interpreting medical images such as CT scans and MRIs. Deep neural networks have been able to achieve accuracy comparable to or even surpassing that of human specialists in tasks such as detecting cancer in mammograms and identifying diabetic retinopathy in retina images. These advances are considered one of the most promising impacts of AI in medicine, offering the potential for faster, more accurate diagnoses, as well as reducing the workload for healthcare professionals. Deep learning has also played an important role in artificial creativity. Tools like DeepArt and OpenAI's DALL-E began using neural networks to generate images, art, and even music autonomously. These models can create artworks based on textual descriptions provided by users or generate new musical compositions by analyzing patterns in large amounts of musical data. This creative capability of AI has opened new possibilities for using machines in domains traditionally reserved for human imagination, sparking debates about the role of AI in artistic creation and cultural production. Beyond deep learning, another fundamental aspect of modern AI is reinforcement learning, a technique based on the idea that a machine can learn to make decisions through interaction with the environment and rewards it receives for correct actions. Reinforcement learning has been used in various areas, such as optimizing supply chains, controlling robots, and even developing strategies for financial market trading. This technique enables systems to adapt to dynamic environments and improve their performance over time without constant human intervention. As deep learning and reinforcement learning continue to expand and evolve, explainable AI, XAI, also became an important topic. As AI models grew more complex and difficult to understand, scientists and engineers began seeking ways to make their decisions more transparent and interpretable. This became crucial in sectors such as healthcare, law, and finance, where decisions made by AI systems need to be justifiable and understandable to the humans using them. With all these advances, modern AI has transitioned from a promising technology to a transformative tool in many areas of everyday life and industry. Today, artificial intelligence plays a crucial role in virtually all major technological innovations, from factory automation to new drug development. What began as a theoretical field of research in the 1950s and 1960s is now shaping humanity's future in ways that were once unimaginable. Next, topics 6 and 7, 6 AI in the future, opportunities and ethical concerns, and 7 final thoughts and conclusion. Did you enjoy the content? Don't forget to subscribe and like the AI for All channel to stay up to date with the latest in technology and artificial intelligence. See you next time.